Okay, today we're going to look at variables and expressions. So let's get some vocabulary out of the way. A variable is a letter that represents a number. Well, that didn't fit very good there. Here, maybe if I enlarge it, that'll help me fit it in there. All right, a coefficient is the number in front of the variable. It's like touching the variable. A constant is a number that's all by itself and does not have a variable. So it's a number with no variable. An algebraic expression is a combination of variables and numbers that does not have an equal sign. We'll say it's a math sentence with numbers and variables, and it has no equal sign. To define a variable means to tell what the variable represents. All right, so let's look at this expression down here, 3m plus 8. So in this example, I'm just going to point out these things that we just talked about. M is our variable. It is a letter that represents a number. 3 is the number in front of the variable, and that is our coefficient. And 8 is all by itself with no variable. That is our constant. So that's what it looks like in an expression. So let's just take a look at what these things mean. When we have a number in front of a variable like 7p, 7 is the constant, p is the variable, it means 7 times p, like we're multiplying them. But we don't have to put a symbol in the between, we can just say 7p. X over 2, we know a fraction is just like a division problem, so that's like x divided by 2. And then AB, again, that doesn't need a symbol in between. We're going to know that that's like A times B. So the little dot also means to multiply. So over here, we're going to take this chance to write some expressions. So let's say we wanted to write an expression for the phrase $4 more than the cost of a hamburger. So we want to define a variable. You could have like the letter C equal the cost of a burger. You could also use just X. You know, X is a very common variable. You can use it for everything if you want to, or you can use the variable that goes with like what the word is, that is the unknown. So if we want to say 4 more than something, we can add to it. 4 more than the cost of a burger. You could write it either one of those ways. Shows 4 more than the cost of a burger if we don't know what the cost of the burger is. The next example is 5 more than $12 per hour. So the thing we don't know here is the hours. So we can have H be the number of hours. So it's going to be 5 more than $12 per hour. So if you make $12 per hour and then 5 more than that, or 5 more than 12 times how many hours you worked. If you make $12 an hour, you would multiply 12 times how many hours you work. All right, moving right along here. 6 pounds less than his brother weighs. So we could have B be how much brother weighs. Brother. All right, so if you weigh 6 pounds less than your brother, you aren't going to do 6 minus how much your brother weighs, right? Because if your brother weighs 100 pounds and you do 6 minus 100, there's no way you weigh negative 94 pounds. We would actually take 6 from how much the brother weighs. So how much the brother weighs minus 6. It's a little bit tricky sometimes because a lot of people want to write it in the order that it appears in the sentence, and the 6 appears first. But when we do 6 less than something, we are going to subtract that from the something. Alrighty, last example here, 8 fewer than 20 kids per team. So each team has 20 kids, and it's going to be 8 less than that. We don't know how many teams, so we'll do... I actually don't like to use the variable t because it looks like an addition sign, so in this case I'll use x. X will be the number of teams. So there are 20 kids on each team, and we want 8 fewer than that. So just like the example before, we want to subtract 8 from the total number of kids on all the teams. All right, so we've got some basics here. Now let's talk about evaluating expressions. So it says to evaluate an algebraic expression, you're going to replace the variable, with known values and then use the order of operations. Good old order of operations. Let's just real quick, order of operations is like parentheses, exponents, multiply and divide in order from left to right, and then add and subtract in order from left to right. All right, so it says to evaluate d plus 5 minus f if d is 1 and f is 3. So instead of d, I'm going to write 1, and then I'm just going to keep that plus 5. And instead of f, I'm going to write 3. So I'm going to do 1 plus 5 is 6, and then 6 minus 3 is 3. So I used the order of operations there. Let's try number 2. Evaluate 7m plus n if m is 3 and n is 4. Well, 7m means 7 times m, not 73, but 7 times 3. And then we'll add n, which is 4. Remember the order of operations says we multiply before we add, so we'll end up with 25. All right, number 3, evaluate x squared minus y. So we're going to do 3 squared because x is 3. And then we're going to subtract y, which is 2. Remember that 3 squared means 3 times 3. It does not mean 3 times 2. An exponent means to multiply something by itself. So 3 times 3 is 9, and 9 minus 2 is 7. And last but not least on these notes here, we have ABC over 2. So remember, that's like A times B times C. We don't have to put the symbol in there. So A is 4, B is 2, C is 3, and then we're going to divide by 2. So 4 times 2 is 8, and 8 times 3 is 24, and then 24 divided by 2 is 12. We got all the notes now. Thank you for watching.